This video is supposed to illustrate some of the prerequisites for pre-calculus in the sense that we have some things in pre-calculus that we assume that we know how to do, and some of these things need to be reviewed. So this particular video will focus on equations that involve fractions. So in this equation we're trying to solve for y. In the equation the variable is in the denominator. The only special rule for dealing with fractions is probably just get rid of the fractions. So if we think about how we normally get rid of fractions, what we do is we try to multiply both sides by whatever the denominator is in the fraction. And when you multiply a number, a fraction like a third times its denominator 3, the 3 and the third cancel out. So that's really the goal. There are some options here about whether you want to simplify this before you're doing that or not. I'll go ahead and do that just to remind you of some other things. Simplifying here would mean, my goal is to multiply both sides by the denominator of the fraction, but there are two fractions. So step one could be combine these so that we only have one fraction to work with. And so that would be the idea of finding a common denominator. So that's where I'll start. And of course there are other ways of dealing with fractions, but this is a method that'll work okay. So, so to get a common denominator means that I need to think about what denominator would be common for these two things, and the easiest thing to use is just the product of the two existing denominators. So if I were to multiply the first fraction by y plus 4 over y plus 4, then that's not really a different fraction. It's still equal to 1 over y plus 1. Similarly, if I were to multiply the second fraction by y plus 1 over y plus 1, then that is not a different fraction. I've just multiplied by 1. And I'll just leave over here the same thing. The advantage now, this doesn't change the equation. It makes it look a lot worse, but now I have the same denominator for this fraction as I do for this fraction. Namely, the new denominator is just the product of the two old denominators. So the denominator for both fractions now is y plus 4 times y plus 1, and that means I can combine the numerators of the two individual fractions into the numerator of this common fraction. So the first fraction's numerator will be y plus 4 times 1, which is just y plus 4, and the other fraction will be y plus 1. Now see, the bad idea to pick 4 is I can't distinguish between them. Y plus 1 times 4 will be the numerator for the second fraction. And of course the equation still says this is equal to 1. So even though this looks pretty bad, now I can follow through on my original goal, which is multiply on both sides by the denominator, and that'll get rid of the fractions in the problem. In this case, the denominator is y plus 4 times y plus 1. So if I multiply on both sides of this equation by y plus 4 times y plus 1, on the left-hand side, I'll be left just with the numerator, and I'm going to go ahead and multiply this out, y times 4 plus 4. And on the right-hand side, I have just 1 that was there originally times y plus 4 times y plus 1. So again, the step that I'm doing there is multiplying on both sides by the denominator in the fraction that I have. And now in this equation, there's only one fraction, and so only one denominator to worry about. So now I'm just simplifying. On the left-hand side, I have 5y plus 8, and on the other side, I'm doing the FOIL method to multiply these two binomials. Y squared is the first times the first, the outer y times 1, the inner is 4 times y, and last is 4 times 1. So I recognize that this is a quadratic polynomial, so I have a polynomial equation. Let me just scroll a little bit, which means that my strategy is to try to get all the terms on one side and have it equal to 0, and then hope that it will factor. So I'll do that. I'm going to put things on the right-hand side because my y squared is already there, so I don't want to have to move it. But I have y squared plus 5y plus 4. So when I subtract 5y from both sides, which is what I would want to do to get rid of it from over here, it's actually going to cancel out over here. So this 5y and that y plus 4y are going to go away because I'm subtracting 5y from both sides. Now if I subtract 8 from both sides, that'll give me 0 over here, and then on this side I'll have y squared and minus 4. The plus 4 that was there is now minus 4 because I subtracted 8. So now this is actually an easy polynomial to factor, or because it doesn't have a y term, I can really think about it two different ways, but I'll just factor. Y squared minus 4 is the same as y minus 2 times y plus 2. And so from that, I can see that my solution set is that y is 2 or y is negative 2. So in terms of a solution set, I would write that as 2, negative 2.